technologies. It's my day job. For several years now, I've been co-editor of this glTF specification. I'm going to do a quick bit of setup, and then the people who are doing a lot of the real work these days are going to get into some significant updates for everybody. How many people here in the room are familiar with glTF, have actually worked with it, use it? So actually a good percentage of you, there's a few noobs in the room, so I won't spend too much time, but I do want to set this up a little bit. Back at around the end of 2011, early 2012, there's a lot of work going on in WebGL, and people were building WebGL open source engines, and then they were building their own pipeline for delivering the assets into those open source engines. They would build exporters out of, say, Blender to get into the 3JS engine, or Babylon.js had some converters from one thing to another. And we rapidly found we were in the situation where a lot of people were duplicating effort for creating a pipeline for delivering assets into WebGL and potentially, eventually, mobile applications based on OpenGL. And so we got to work on this, what became a standard, this technology called glTF. Thinking of it relative to Collada, which was the previous Birds of a Feather session that just ended, that was never designed. That format is also a Khronos format. It was never designed to deliver your data into the application as the end result. It's big, it's built in XML, it's designed to preserve all the data so you can move it around between applications in the back room in your content pipeline, but it wasn't designed to deliver the thing into the end application. And so we really found this need to devise a format that was compact and fast to transmit. It is really tight, it's basically a little JSON file and then compact binary data for all the big items. Could actually cover enough functionality. It wasn't a simple format for just models like, say, OBJ. We already had enough of those. And it was designed for delivery into a runtime, but it's runtime neutral. There's nothing, it's not tied to a specific engine, right? So those are the main requirements going to glTF a few years back. And back in 2014, we actually delivered the first standard. And we spent the last few years, did we get ratified in 2014, Patrick? 2015? I can't remember exactly now. 15. We were fully ratified by Khronos, became official. And then the last couple of years, we've been working on a new version of a standard 2.0, which we just rolled out last month, or in June. And we'll talk to you about that in a little bit. So once we got to this point where we had created a delivery format where you could basically solve these downstream pipeline issues, we realized there's also these other opportunities. Once you had transportable 3D content with full scene data animations and the like, now we're in a position where there are whole new classes of applications for effectively sharing these, whether it's Sketchfab for model sharing, whatever it might be, that it could become the YouTube of this world. And there's going to be a proliferation of 3D content out there with a format like this. So we're really excited about this. There's a lot of industry adoption going on around it right now. And that's coming from different pockets. So, we solved this downstream production pipeline problem, and then a year and a half ago, the Oculus folks came to us and said, well, we're solving exactly this to try and get this into mobile for Gear VR. So all of a sudden, it becomes an interesting format for delivering into a Gear VR application. The folks at AGI, Patrick, my spec co-editors from AGI, they have this product called Cesium. It's an open source framework for geovisualization. Absolutely amazing. They've put a lot of work into this. I mean, you go down the list of this logo wall, and it's growing every day. People see the need for this format, and there's a lot of open participation. We're all working together to solve a common problem around runtime delivery of 3D. And now, what's really exciting about 2.0, which we just announced we're going to dive into today, is we've overhauled a couple of important aspects of the system, and we're going to tell you a lot more about PBR and show you things in a few minutes. But we've added a basic PBR, physical based rendering system. I got another slide on this in a second. One of the key differences now is originally glTF, and the name, it's in the name, was built on OpenGL technologies, WebGL, OpenGL ES2 concepts. And you would deliver your shader content and some of the other programmatic constructs tied to GL shader language, other API constructs like the passes and other things that are in how you deliver your graphics content were kind of tied to OpenGL concepts. Well, we broke that, and we've now made it API and shader language independent, which is huge. We also added something we needed to add last time we didn't get to, which is morph targets, and along the way we came up with a couple other core constructs to enable morph targets, like sparse accessors. When you do morph, you don't want to replicate the data for every sequence through the morph, so you basically have to represent that data sparsely. We've done that. And then we've also just tightened up the format and made some things more efficient. We've gotten rid of a lot of levels of indirection we had originally, which we thought was going to give us a lot of flexibility. All it turned out was implementers started looking at it, and there was a lot of WTF. And in addition, there's efficiencies from compacting things a little bit more. And so there's a whole list of changes. You can go online and check out the spec. And this is all being done in the open on GitHub. So really quickly, if you don't know what glTF looks like, there's a scene description in JSON, JavaScript object notation. which describes all the objects in your scene, how they relate to each other, all the animation constructs, all the nodes. But then there's binary data that comes along with that payload, either as a separate file or built into the same package that has all your rich data in it, your meshes, your keyframe animation data, and the like. And then there's external assets for your PNGs and your JPEGs. And again, now that we've moved to a PBR system, you no longer have these external GLS shaders. So yeah, with our PBR, we took a really simple kind of approach. We didn't go quite lowest common denominator, but we picked the simplest metallic roughness material model, if you're familiar with these PBR models. Easiest to implement for implementers, and our goal there was fast implementation, getting people using this. We didn't want, creating a complicated PBR shader built into your engine to become, one of the impediments to people starting to work with this. However, that being said, a lot of folks like other PBR models like spec glossiness, and we've added that as an optional extension. We'll see how that goes. And the way extensions work, it's in the Khronos world. It's similar to the rest of the Khronos world. You can experiment with an extension as third parties. You can create an ecosystem around it. That's something that may ultimately get into the base spec, but it's not today, and it's not required to implement it and be conformant. And again, I mentioned this really quickly, but in the interest, since we started late, of moving fast, one of the things we're most excited about is physically based rendering for a couple of reasons. First of all, it kind of keeps us modern. I mean, PBR is the way a lot of engines have gone over the last little while. I mean, I know we're at SIGGRAPH, so that probably feels like old technology at this point, but it's kind of where the industry has really arrived to. But more importantly, by going to a model like this, it makes us independent of a shader language. It makes us independent of a graphics API. So now we have DirectX implementations of PBR. We have Vulkan, we have Metal, and we have WebGL, and these are all working in existing engines and applications today. So with that, I want to turn it over to Patrick Cozy from AGI, spec co-editor. He works diligently on this. He's building products and frameworks in this area. Take it away, Patrick.
Thank you very much, Tony. So just about an hour ago, we realized that this is actually the first ever glTF BOF. We've done a Collada and glTF BOF. We've done WebGL and glTF, but this is the first one that's glTF standalone. I think we have an incredible audience, incredible turnout here. It's just showing the interest and the momentum behind glTF. We like the spec, but what we really like is the ecosystem that's forming around the spec, especially the open source software, because that's really going to let us move the field forward and collaborate and get a lot done. So with glTF 2.0, we are seeing some pretty incredible adoption pretty quickly, even as we were working on the spec. People who are editors or even just community contributors really adopting very quickly. On the tool and export side, we do have now in beta a Blender exporter open source by UX3D. A lot of people have been using it. Please go, if you just Google glTF Blender exporter, check it out on GitHub. We'd love your feedback and bug fixes and issues, very welcome. We're going to see a great demo today, glTF plugin in VS Code. ASIMP, very aggressively supporting glTF 2.0, which is great. OBJ to glTF is imminent, is hours away. I think I see Sean coding on it right now. And then we have other things in the work with the glTF pipeline and Collada to glTF. On the engine side, we're really good adoption. We've consistently seen with glTF engine developers really loving it, adopting it very quickly. So we already see 3, Babylon, Cesium, hot off the press yesterday. Cesium just shipped glTF 2.0. A-Frame has an add-in for it, seen it throughout the Microsoft ecosystem, putting it in Office. Super exciting too, Sketchfab has glTF export. There's 100,000 models that you can export with glTF. Thank you, Sketchfab. If you look to the top right here, some things that I think are really important is we have a good validator. So this will help you if you're writing an exporter, know you're exporting glTF correctly. If you're writing a loader and you think you have a bug, make sure that you validate the model first to see which side of the pipeline it's on. Great set of test models as well, and a lot of them will have kind of debug information. Are my texture coordinates right? Is my metal rough set up correctly? All online on GitHub. So please, again, check out the Blender exporter. Here's the URL for it. And this is showing Poly, which is the new glTF model. So that will become available soon. It has morph targets, skins, everything, PBR materials. It's a great, complete systems test for glTF. We're going to hear from the Google folks today. We're super excited for Google Draco Mesh and Point Cloud compression. They've reached 1.0, and then they have a draft glTF extension. This is really good stuff in terms of much better compression than gzip, decodes very quickly, can decode in a web worker, and open source encoders and decoders. I think this is going to be huge. Really looking forward to their talk. And then we are looking beyond 2.0 and what types of things should we be looking at, and we really need your input. This has been community driven since the start, so we are looking at different level of detail approaches, texture compression, just improved texture support for things like environment maps, and we'd love to talk with you after the session or tonight at the Khronos party about what you'd like to see. In addition, other ways to engage is if you go on GitHub, we have 2 issues here. Issue 4, 5, 6 is all about the ecosystem. Tell us what tools you think we should be working on. If you're working on something, let us know. We'll help spread the word. And then issue 1051 for the spec itself. So with that said, I think now's a great time to update to 2.0. We've been doing it in season, and I do believe when people start saying glTF, it's just implicit they mean glTF 2.0. So with that said, I'm going to get the slides out of your way because we have a great set of demos from people from Microsoft, Google, Sketchfab, Autodesk. The list just goes on. So thank you very much. Are you guys?
Is this working? Is this working? Yes, it is. While they set up, let me set up. There's a new T-shirt, by the way. Go get it. And it's got some just the right amount of geeky PBR logos there, right? Oh, it is working. Yay. Right. Yes, so now we are ready. glTF 2.0 with the PBR logos there. Cool. I guess we are ready to go. So I'm Saurabh Bhatia, part of Microsoft, also joined by Gary Zhu. Hopefully this isn't echoing too bad. All right. We've been part of the glTF community for about a year now and have participated in the 2.0 spec and in various open source contributions that you're going to see throughout this BOF session. In this section, we'll kind of focus a little bit on Babylon.js, or WebGL open source 3D engine, and then switch over more to the consumer scenarios. So a few weeks ago, we released Babylon.js 3.0 with support for glTF 2.0. We've actually updated the PBR APIs inside Babylon.js. That's a glTF model. You're going to see that a lot today. Our APIs now actually match what the glTF material definition is, so you really get a consistent experience whether you're programming against it or just loading up the file. We've added the new features like morph targets. That's a nasty-looking alien there, a little creepy, which is now supported in Babylon.js. And then finally, we also have a viewer which we call the sandbox, where you can just drag and drop your glTF files and just view them right in the browser. So it's a nice way to test out your glTF files. You can find out more about this. I think Sebastian, who might be here, is going to talk a little bit more about Babylon.js and Spectre.js in the WebGL section. So switching gears a bit to really our consumer apps and how we are bringing glTF really to everyone. So View 3D and Paint 3D are 2 apps that are now available on the Windows Store, and they support glTF 2. Gary, you want to walk us through what you can do with these?
Sure. So real quick, Suzanne is a model that I exported from Blender. And it's just as easy to open just as pictures and videos. You can just double-click on it, and it should open in View 3D. So we're going to do something fun with this. And real quick, we're going to open it up in Paint. And you can see that it's now in Paint. So what I'm going to do is do something fun. We're going to add some sunglasses to the Suzanne model. So I'm going to place this in the scene here. It's a little too big, so I'm going to shrink it down. And move it up a little. It's probably still a little big. And we're going to actually place it in 3D onto Suzanne. Oops. And just like that. So we're going to do a little bit something fun here. I could now save it as a GLB again, but we're going to place this actually in mixed reality.
Let's see if this works.
Let's see if it works.
Maybe you have to be here to be in the picture? Maybe not.
Give it a second.
Lots of machine switches going on. There you go. Maybe right next to Patrick and Tony then.
Yeah. Sorry, it's a bit slow right now. I'm going to place it right there. Hi. I'm going to take a picture. So maybe I can tweet that out a little bit later.
Cool, yep, we will tweet that out. So that's Paint and View 3D. It's already out there. You can go get it from the Windows Store. We continue to push out updates to it. If you want to be on the fast track and get like the improved glTF2 support, you can go sign up for the Windows Insider programs, and then you'll just be on the fast track of getting more of these glTF 2.0 updates. Something else we want to show is 3D in Office. And unfortunately, because of the little laptop issues, you missed this in the intro videos, but I think we can show you how easy it is now to add 3D to your PowerPoint presentations. Gary?
So I took one of the slides from the intro deck, and what I'm going to do is insert a 3D model right here. Get the mouse out of the way. So right here, I'm going to insert a boombox. Give it a few seconds. And what I'm going to show you is how to create an animated boombox in PowerPoint. So I'm going to shrink this a little bit down. And very quickly, in order to create an animation, all you have to do is duplicate this slide, orient the object the way you want it to be oriented. So let's say like that. Go to Transitions. Click on this very simple morph transition. You'll see that your PowerPoint is now morphing from one slide to the other. So you can see this is how easy it is to create transitions in PowerPoint. Now you can also do this in Word, Excel, and Outlook. So to give you a more polished version of this, we have a pre-baked version of this PowerPoint with the Hubble telescope. So you see the model is now transitioning in. It's rotating in. You can have annotations that point to the correct locations. Everything looks really cool.
I think that's really going to change the way we see presentations going forward, right?
Yeah.
So if you want early access to all these bits, you can go sign up for the Office Insiders. This isn't out yet, but it should be out soon. It'll be great for you to try it out and give us feedback on how you see this coming. And of course, I have to reiterate, all of this is glTF, right? So before we go, there's one last thing we want to show you. If you noticed, in a bunch of files out there, these are all glTF files. Something called It Takes a Village. I wonder what that is. Does that look familiar to anyone?
That's Minecraft.
Yes. So Minecraft is going to add the ability to export your 3D creations and make them available in Paint and Remix 3D. But it is all through glTF. So anyone who can read a glTF file can now consume all these Minecraft assets out there. So I think this is great. glTF has created a huge ecosystem where you can create multiple 3D assets, share them across engines. And at Microsoft, we are committed to kind of keep this going and create an open and interoperable ecosystem based on glTF. So can't wait to see what's coming next. Thank you.
Thank you.
So hi, my name's Ed. I work with the Cesium team at AGI. In my free time, I came across a lovely Microsoft product called Visual Studio Code, not to be confused with Visual Studio. This is a text editor similar to Sublime. It's based on Electron, which means it has Chromium built into it, which means it can show you HTML preview windows. And so I decided to build a glTF extension that lets you load a glTF file, and you can edit the JSON in the file, and then you can simultaneously also see the resulting model and move it around in 3D. And a quick shout out to another Microsoft employee named Howard Wolowski. He actually contributed multi-engine hookup. My first cut of this only had the Cesium engine, of course, and so you can see Howard hooked it up to Babylon and 3JS. I'm going to show you briefly. We can see the reflection map that's being reflected here. You can configure that to be any reflection map you want. And the other, try not to damage my model because that will break the demo. The other thing I wanted to show off is, well, actually, I didn't actually show you the Cesium engine running yet. We'll save that for later in my 5-minute rush talk here. The other thing you can do, this is an ambient occlusion map that's part of that helmet, so you can quickly preview these different textures that are in the glTF structure. That's the albedo or the base color map. And you also have the ability to convert these things. Right now they're separate files, but you can run a command called glTF import file, and it will convert it into the data URI. And that's bidirectional. There's an export. It'll export that back to the file. And of course, you can still preview that as a data URI. So if you get one of these models that has these things baked into it, you can still see what that looks like. So I said I was going to show you the Cesium engine. That was released yesterday. It's brand new. And in here, it works. It seems to have reasonably good performance. The reflections here are a little bland. And to understand why that is, we're going to go look at Cesium proper. Cesium is of course geospatial. It has roots in the aerospace industry, and here I've got the model. We're just using we're not doing the full expensive reflections. We don't think Cesium users necessarily want to have a ton of models and computing all these reflection probes and everything. So we just have sort of a horizon gradient. We may revisit this in the future and add the full reflections, but I will show you that. I've got this model on a path that is essentially just going straight up in a completely unrealistic fashion just to leave the Earth, just to be able to try out these reflections at different altitudes. And you can see the sort of false horizon moves correctly as we move away from the Earth. And of course, Cesium has accurate timekeeping. It gets its name from atomic clocks. So this is a real star map. It's exaggerated brightness star map, but the stars are all in the real locations. And so if I zoom in on the visor of the helmet, you see the Milky Way is reflected there. And I'm going to make the bold claim that Cesium is the first framework to offer astronomically correct PBR reflections from a 3D model into the star map. So there you have it. That's all I got. Next speaker.
Awesome. Thank you, Ed.
Okay, so I just have 5 minutes to show something real quick. So my name is Nop. I am a WebGL developer from Autodesk. And I'm here to show you that our Forge platform now supports glTF. So what does that mean? Those who aren't familiar the Forge platform is basically a set of APIs that is exposing some of Autodesk's proprietary technology. Some of that includes data management APIs and viewing API on the web, translation services. The one that I'm going to be talking about in particular is our viewing/translation API, which basically allows you to share, view, and explore your mechanical architectural designs on the web using some of the tools that we have. And we have full PBR reflections and all that good stuff. Shadows and everything. So So real quick, I'm going to jump into this, the free viewer that we are offering. So you can just go to viewer.autodesk.com and just sign up, and you can share any design files. What I want to show today is you just drag and drop the glTF file. Maybe not. Needs a little refresh. Okay, we have to sign in again. Okay, all right, we're here. There we go. Hopefully this will work on the Marriott internet. Okay, all right, once it's uploaded, we should be good to go. Processing is all done in our backend server. Won't have to worry about that. And we should be seeing our friendly sample glTF file that I just downloaded right off the repository. So, so that's glTF, again, displaying in the Autodesk viewer, going through the whole translation pipeline. And you still get all the features. You can explore the entire hierarchy that's preserved from the glTF structure. So you can go and find the person here. I think I found him before. The driver, and then you can isolate him, just see, go through all the pieces. And basically just, if you are in at glTF, then you can, of course, leverage all the features that we have and do all sorts of fun stuff, like you know, pulling to pieces like that. And that's about it.
All right, hi, I'm Don McCurdy at Google, and Ricardo, or Mr. Doob, and I are going to talk about glTF support in Three.js and A-Frame. If you're not familiar with it, Three.js is JavaScript 3D library that works across mobile, desktop, VR devices, and lets you have a good WebGL API in JavaScript. Three.js already supports glTF loader for glTF 1.0, and then new in the last couple of versions of Three.js is glTF 2 loader that gives you support for all of the glTF 2 core features, from PBR and the metallic roughness and the extensions for specular glossiness. You can bring in your animations from other tools, including morph targets, scanning and rigging, and then Three.js supports both the ASCII and the binary formats as well. And I want to say a particular thank you to Takahiro, who worked on the PBR and a lot of the animation support for glTF in Three.js and did a really great job there. I've also put together a drag and drop viewer that you can use to test out your models in Three.js and to make sure that things look the way you expect them to. And so that's at bit.ly/glTF viewer. To do a quick preview there, you can just drag in a file and preview it in here. I can bring in a whole folder with my textures in it and so on, and get a live preview of that and check it out in Three.js. This is helpful for artists if you want to be confident that something's going to work the way you expect it to in Three.js, get really quick feedback, and iterate on things as you're developing with importers and exporters and your different pipelines.
All right, so while he was talking here, presenting here, doing an update for glTF on 3, somehow I realized that glTF started supporting morph targets, and ROM is a project that we did now 6 years ago at Google for demoing, like promoting WebGL actually, when it was released. For that project, this company did a lot of those animals, 3D models, and also animations. And somehow I thought that it would probably be a good idea to also test the exporters and the loaders to try to like recover all those models. Like when we did that project, we released all the models, but we had a proprietary, not really proprietary, we just did what we did. There was nothing at the time, so we did our own JSON format for that. So we had around like 75 animated models, and we released them with the CC license, but people couldn't really load them because it was all very part of like three kind of loader kind of, or like kind of like three format at the time. So for the last weeks, I've been like trying to recover all those files and like convert them to glTF, and in that way, like trying to like stress test a little bit the Blender exporter. In the process, like we found like there was a lot of issues on the Blender exporter and on dealing with more targets and animation, also the file size. Like originally the files were something like 10 megabytes when I was exporting instead of like 200 kilobytes. Now it's starting to get down to like around 400 kilobytes for a glTF file. And also in the process of doing all this, I also realized that GitHub Pages doesn't gzip, glTF, or glb formats. Submitted a pull request to wherever I think they have something like a MIME type database somewhere in the system, and they approved the pull request. So on the next version of the update of the GitHub Pages, all the glTF files that are on GitHub, they're going to be served as gzip, so it's going to be much faster. How do you change the escape? All right. So this is what I have so far. How do you go full screen again? There you go. No. Whatever. So, so far, I'm still working on trying to like clean them up, trying to like make. I also found some issues with looping animations in the exporter that we need to find what the best way to deal with it. But like the idea is to be able to like to put this page up so everyone can like just download all those files and try them on your own engine, or you use them on your own applications. Hopefully, I'll be done probably next week with all of them. And yeah.
And then the Draco team is coming up right after us to talk about their mesh compression library, so I'm not going to say too much here. We've been really excited to work with them, adding 3JS support there's already support for the geometry compression loader in 3JS, and then coming soon is going to be supporting the glTF and Draco extension within the 3JS glTF loader, so that you can have animated PBR scenes taking advantage of Draco compression. And then I'm also going to say a little bit here about A-Frame. So A-Frame is a web framework built on top of 3JS for building virtual reality experiences using a declarative HTML syntax that's easier for web developers to pick up. And so A-Frame has built-in glTF 1.0 support in the core library right now, and there's an add-on you can bring in just as an extra dependency that adds glTF 2 support to that. And that'll be rolled into the stable A-Frame support release with the next release in a month or two, very soon. And so the way that works in A-Frame is you can just bring in a scene tag, add an entity to your scene with the glTF model loader attached to it, and then A-Frame takes care of setting up a renderer, setting up a camera. If you have VR hardware attached, it can connect to that and present in VR for you. So this is just like a really easy way to get started building VR content with glTF as well. So the point I think we want to leave you with is that it's a great time to start using glTF 2 in your web projects. You can use that in 3JS and A-Frame and the different engines you're seeing today. And next, the Draco team is going to talk about mesh compression.
Hey everybody, I'm Jameson. I'm with the Google Draco team, and I think we have some pretty cool stuff to talk about today. So if you're not familiar with it, Draco is a mesh and point cloud compression library, completely open source, completely royalty free. So get out there and start using it. It's pretty cool. So I have a few numbers to share just to show you kind of the scale of the compression that we can get. We started with the simple Stanford Bunny, because where else should you start besides the Stanford Bunny? So it's about 1.3 megs uncompressed. After using Draco, we got it down to about 60 kilobytes. So a pretty huge number in terms of compression. I think it's about 20x over zip, so, or over uncompressed. So a pretty huge compression ratio. But what's also key to Draco is that it's very fast while in the browser. So we have a JavaScript decoder for these models, and decompressing this model was on the order of about 20 milliseconds on a fairly decent computer. So that's a fairly boring model. So we found something with a bit more complexity. So this is a 3D room model with a bunch of different stuff. So we have connectivity information, the position of the vertices, different colors. The scene was about 40 megs uncompressed. Taking it with Draco, we've got it down to about 2.6 megs. So compressing all those attributes and the positions and all that stuff. So some pretty great results just off the bat. So this library came out first thing in January, so as kind of a beta, early access type of thing. So for the last 5 or 6 months, we've been heads down on kind of the 1.0 release, and we're seeing some pretty great gains in the last 5 months. So we had a 20% improvement in compression of our models since then. We've released a WebAssembly version, which was twice as fast and half the size as a decoder. Some package management improvements, a JavaScript encoder, just a ton of stuff. So, and probably one of the #1 feature requests that we had was whether the model can then have metadata associated with it. We added that support in this release. So a number of really good improvements. And as been alluded to in a couple of sessions earlier, we have announced that we'll be proposing an extension to the glTF 2.0 spec. So this is going to have some great impact across the board. We have the bitstream up on our GitHub, so please check it out, comment, feel free to look at that. That's exciting. And then we have a number of examples that are out there with the Collada to glTF with Draco, the glTF pipeline with Draco, and then, as previously mentioned, 3JS plus Draco and other glTF objects. So a lot of really cool work, and we're excited to help out as we can. So if you want to learn more about what's going on with Draco, you can get it on our GitHub. There's a lot of our examples, our decoder, all of our source code, as well as a number of examples. Moral of the story is we're open for business, so if you want to contact us with any questions or requests in Draco as it pertains to glTF, we're all ears. So please feel free to reach out to us, either on our mailing list or just through the GitHub tracker. That's all.
All right. I'm Scott. This is Mohammed. We both worked on the glTF PBR reference implementation that's available on GitHub. What we're going to talk about here, we only have 5 minutes, so we're not really going to go super deep into like the fundamentals of PBR. SIGGRAPH has a lot of resources about that, especially the Cell Shadow blog. They have like 5 years of PBR courses, all the course notes, slides, everything like that. So I encourage people to learn about it. Advances in Real-Time Rendering has a bunch of stuff on it, and basically there's just a lot of information from SIGGRAPH about PBR, so I want you guys to go and do that. As Tony talked about earlier, the reasons we got to glTF, or PBR and glTF, are glTF 1.0 mostly had just custom GLSL. There's some extensions that had specific material models, but most of the assets were delivered just with random GLSL. That led to poor compatibility because you had to have a GLSL interpreter, poor scalability because you couldn't really structure your fallbacks for different platforms. It constrained your visual look, and it made it difficult to compose different glTFs from different sources into one scene and make them look coherent. Basically, if you wanted to, reflect the Milky Way in a random GLSL or glTF file that you got, it was difficult to do that. So for glTF 2.0, we needed a declarative surface property model. We needed values that could be interpreted in a specific way. We wanted to enable engines to be able to innovate with the math that they used, but still have the same core properties. And we wanted to be able to tune it for different use cases and platforms. You should use it in a path tracer, or you could use it on a mobile device. And we want the same assets to go cross-engine and cross-platform. And we wanted to be able to combine them with consistent quality. So for glTF 2.0, the material is decoupled from the lighting implementation. There's no more shaders in core glTF 2.0. There's an extension to do that, but we hope people use PBR. So Mohammed will talk more about what the PBR in glTF 2.0 is.
So in case anyone needs it, just in its most simple definition, PBR just refers to any set of implementations where you try to simulate the interaction between light and a surface based on its material properties based on mathematical and physically based foundations. So that can get really mathy really fast. So part of the glTF spec is to maintain this power of PBR while keeping it lightweight along the pipeline for artists to be able to encode these materials. And one of the most popular, which we ended up going with, was the metallic roughness model. Typically preferred by content creators, however, as you guys have heard, spec gloss is offered as one of the official extensions. And one thing to note is that right now we're really only talking about BRDFs, so encapsulating like physically based reflections. We're not talking about refraction and physically based transmission at this point. So as you've seen, we have metallic roughness parameterization for materials, and you can see this is simply, you need the base color for the albedo, metallicness and the roughness, and the shader does the rest of the work. That's really all you need. And in order to get the most out of your models, you can add in normal maps, occlusion maps, and emissive maps to add in an extra layer of detail. So with that, we can go straight to the reference implementation itself. Oh, sorry. Okay, so here it is running in Chrome live. You can see here, this is just an array of spheres that carries all the material properties, down metallic, varied metallicness and roughness. And you can really encapsulate a lot of materials that you couldn't before without PBR. And so this will, help a lot with, creating really immersive, realistic assets. And just to bring this back, everyone is really infatuated with this model because reflections are pretty. We all love pretty reflections. So yeah, running in the web, it's really powerful, a really powerful file format. And you can see here that you can pick out the base color, metallicness, and roughness features, and also look a little into the different math components, which are all available open source on GitHub for you to look at and see where all these math foundations come from. I think I closed it. But cool. So in general, open source means collaboration. So we're talking about, this is kind of a starting point. We want people to take things from here, kind of make PBR accessible to everyone, and have people expand upon it and really introduce as much as they can and make, glTF, or showcase what they can with glTF. And as we've talked about, this isn't engine specific, so we can see the same kind of fidelity in Babylon.js, 3JS, Unity, Unreal, Cesium, and now even PowerPoint. So that's all we have to show you. Please visit the reference and let us know if you have any comments. Make PBR accessible to everyone. And thank you to Ed Mackey, Alex, Marco, and Saurabh for all of the help along the way.
So, hi, SketchUp and glTF. So briefly, SketchUp is a platform to publish, share, and discover 3D content on the web, also on mobile, in VR and AR. So quickly, who am I? I'm Orion from SketchUp, and with Mark from the SketchUp team, we worked on the glTF support and export. So why did we choose glTF? The main reason is the introduction of the PBR materials in the core specification. So now we can have our whole material description inside the file. So it's very, very useful. And a few bonus points. It supports animation, so we can also have a solid rig and mouth animation. It's a web-friendly file format, and it's free and open, so that we can contribute to all the tools around glTF. So that's cool. A few words about the current state. So today we support glTF 2.0 on the website, including a specular PBR extension and all the type of animations inside the file. Since the last release, we are also able to get glTF content from all the downloadable models from Sketchfab, in addition to their original file formats. So all this, and we also have the Unity exporter and the experimental importer to get and export the assets from Unity to Sketchfab and so on. So yeah, all this work has been based on a few projects around glTF. So first, thanks for members who pushed PBR in the core specification that made glTF a very nice format to transport nice PBR assets. Our glTF parsing and serialization is based on the C++ header library called Tiny glTF. The Unity exporter is based on the Unity glTF exporter plugin made by Tony Parisi. And the experimental Unity importer is based on the Unity glTF plugin from Outspace VR. So yeah, quick demo. Sorry. Sketchfab. Quick. Go. So here, basically, you are on Sketchfab. You see a nice downloadable model. You just go on the page and click on the download button. And then you will have two possibilities, the original file format or the glTF version. You just have to download it and you get a zip with everything packed in it. So yes, another model. Up. So it's pretty easy. So let's check the result in Three.js. Up. So yeah, it works. Up. The other model. It's now in OHGS. The same, drag and drop, and you get the PBR set rendered with all the maps. Same here. And now in Unity, so with the importer. So you just have to decide where you want to put all the assets of the model, and then it will load the object in the scene and create a prefab so that you can just reuse it in your game or in your project. So it's yeah, the dragon model, the same. Yeah. And that's it. Up. Well, so back to the slides. So now Sketchfab has the largest glTF library on the web. So you have more than 100,000 models available in their file format and also in glTF under Creative Commons license. So a few words about the next step. We still have to release the animation export with solid, rig, and morph. We also have some work to do on the cleaning the assets, cleaning the outputs. We have to improve the workflow between Sketchfab and Unity, and also add the same workflow between Sketchfab and Unreal Engine to allow importing assets in your game engine. And also the download API that will allow to every tool using glTF just to get content from Sketchfab and include it in their project. And just the last word, so all the assets that are coming from Sketchfab pass through the validator, so they are guaranteed to be valid and usable everywhere. Thanks. So, and the last word, so we can give some rest to the helmet. There are a bunch of other models to use. So the mic to Max.
All right, thanks. I'll keep this one really concise. So I just want to show you a bit of what we're doing with glTF and what was our main motivation of contributing to it, and why we think glTF is a unique format with unique advantages over other formats that are out there right now. So our use case with Instant UV is that we are trying to come up with a pipeline for 3D optimization, and that is going to be fully automatic. And we're starting usually with a 3D scan that is not optimized, so high resolution, has vertex colors or textures or whatever, and then we end up with an optimized asset that is low poly, has normal maps, and so on. And we can directly visualize that on the web. So that's our main target platform. So what we're doing is decimating the asset and then generating UV segments, parameterizing them, packing them into an atlas, and then using the original to bake some maps. And finally, applying some optimizations for rendering, like vertex cache optimization and so on. So with glTF, we have actually now support for all of these maps that we're looking for. So we can generate normal maps, occlusion, and then hopefully soon metallic roughness as soon as we get the corresponding input from the scanner, which is not so easy. And so one of the main requirements is that the asset must be really compact and fast to load with minimal processing overhead. So it must be really ready to render. And note that this is something that we don't have with OBJ or FBX. So if you think about like just an OBJ file where you have your UVs and your positions indexed, you will want to generate a single indexed representation for rendering and stuff like that. And with glTF, we can just really push the buffers that we get to the GPU and render them. And it aligns really well with web technologies as well, as you know. And finally, the bonus point that was mentioned before is that it's really an open format and we don't need a proprietary SDK or something like that. So, and finally, as we have seen, there are a lot of renderers that we can serve. And this allows us to be really flexible, and if our client is running, say, Babylon.js, we can support that. If he's running Three.js, we can support that as well. And actually, right now, what we're doing is we're exporting a template. So we're having a template viewer that is an HTML file, and you can basically exchange that, pretty much what Ed showed previously. So you can have the same asset being rendered in different template viewers, and you can pick the one you like. So, and before I finish this, I just want to point out one very interesting particular advantage of glTF and what it means to be ready to render compared to, for example, OBJ. So the neat thing about glTF is that we have actually specified all of the nitty-gritty details. And if you think about this very simple example of having a tangent space normal map, you need to know where's my UV origin, okay, and then how do I encode my tangent spaces? What about the handedness? Am I having a right-handed or left-handed coordinate system? And sometimes tools are flipping components from the texture, like the Y component, and then in order to match that with some system. And this is really dangerous because, I mean, if the pipeline should be fully automatic, it should work in all cases, then you really need to be sure that your baking tool produces something that is really consistent with your renderer. And glTF is actually a great format, so in contrast to OBJ, it allows us to specify all these details, and when we export it, and if the renderer implements the spec correctly, we can be sure that it's going to be rendered correctly. And here's a very small experiment where I actually took that asset that you just saw and had a normal map and uploaded it to SketchFab with default parameters. And as you can see, for the OBJ version, our baking tool does not agree with the default from SketchFab. And if I go to the 3D settings and uncheck the flip Y, it actually looks nicely. But that's the main point. It's an external variable. It's not something I have in the OBJ file. I cannot specify it. OBJ is not meant to be like that. And the glTF version is ready to render. I can just upload it to SketchFab and it looks correctly. It works. So I think that's one of the great advantages that we have here, that it's really ready to render. So the takeaways are just that we picked this format because it's really flexible, has some great advantages, and there's a massive adoption. There are all kinds of viewers that we can serve. And it enables us to specify everything that's needed to render the asset. And we can really be sure that it's going to be displayed correctly. So with that, I want to close. And I think Patrick has an announcement.
Thanks, Max. And once again, thanks to all of our speakers. We're only 5 minutes over, so really great job with the time. So really inspiring. once again, thanks to all the speakers. Please join us at the Khronos after party today at 5:45 p.m. And Neil, is it okay if we did some questions right now since we're going to? So if anyone has any questions about glTF in general or for any of the speakers here, we'll put them on the spot. Please.
Thank you. Great presentation. Great work. I heard Sketchfab mention a glTF importer for Unity. And I was just Googling around. I couldn't find it. I was just wondering if that's been released yet. And if it has been, what the URL might be.
Yeah, I believe it has been, but I'll turn it over to them. Yeah, come on up.
So yeah, it's still experimental. So just that's just a shot to just a proof of concept. So it's not shielded, but it will be probably pushed, so you can use it.
Onto that. Yeah, I think Sketchfab has an exporter and importer. There was also an AltSpace VR Unity importer. Some interesting things happening there. We have a Khronos repo where we are calling it just Unity glTF tools. I think our goal is to actually try and, there's been a couple of attempts, try and consolidate them and bring them into that one repo. So if anyone's interested, please come see me, Patrick. We are hoping to just get it all out in one repo and collect that effort together.
Do you know if the AltSpace repo is glTF 1 or 2?
It's 2.
Great.
Yeah.
Hi. How would you compare Orbex to glTF? What is the differences, or how do you compare the two of them, basically?
Compare what to glTF?
Orbex format from, I think it's OTOI,
Okay.
and glTF as a transmission format?
Yeah, I'm actually not familiar with the OTOI format. Is anyone else?
There was a talk yesterday in SIGGRAPH about OTOI and the Orbex format has been proposed into MPEG-I as a next generation AR/VR format, basically. So I was just wondering, what is the difference between the glTF and Orbex, basically?
Okay. Yeah, for me to answer that, I'd have to know about the Orbex format. So does anyone else work on glTF now? Yeah, if you maybe give me your card afterwards, I could try to get you some
all right. Thank you.
Good answer, sorry.
Hi, I have a question for the Google guys about Draco. Can you set the level of compression? So could that library be used to produce several models in different LODs?
Yeah, there's a number of different ways you can change the compression levels, either just on level of quantization of the bits, or just we have an actual setting for compression level. With respect to LODs, that's something that's on our roadmap to investigate how we would export it as part of the engine itself, but there's nothing, it could be possible like out of the gate, but I think we could talk offline and figure out what you're trying to do and if we could help.
Thank you.
Are there any plans to move towards support for GPU compressed images like KTX or DDS formats instead of JPEG and PNG?
Yeah, so there's been a good bit of talk on that, and we have been in touch with Binomial, who's a Khronos member, and they've been looking to do a GPU neutral texture compression format. So we're definitely going that direction. And I believe with PBR, we're just going to see more and more big textures, so it's going to be really important.
Thank you.
Hey, Christoph.
Hello. So I have a stupid question, but that's maybe my ignorance. So with PBR, or just for the matter of performance, we could want to pack the data in specific ways, and I was wondering how free, in the format, can we encode the data in a way that is friendly for our engine? So for example, sometimes in the engine we are fine to have just 2 values for the normal map, and we will want to put on the alpha channel or something. And I was wondering how flexible the format was.
Okay, I need to turn it over to one of our PBR experts. Ed, do you want to answer it? Or Scott? Don't all jump in.
So the core format has very specific texture packing. Your normal map, your PBR parameters and stuff like that, they're in specific channels with specific textures. I know some people have proposed extensions for their use case for different packing. I think trying to figure out a way we can generalize that in the future is like a good topic of discussion. Okay. So we don't have just specific extensions for different backing in the future.
Okay, perfect. Thank you.
Great. Thanks, Scott. Hey, Mike.
Hi. I heard the word Unreal mentioned a couple of times, which really gets me excited. I was wondering, is something going on there, or are those future plans? Heard it from SKetchFab, and I believe somebody else mentioned it too. I was wondering if glTF import for the Unreal Engine is somebody's working on that right now.
Yeah, Sharab, do you want to answer that, or who's the?
So we had an intern try this out, and it seems to be working. And our goal is to actually try and push that out in open source. And there's certainly an interest. I think the Sketchfab guys are also interested in it. So it's very early. You probably just saw that one screenshot. But our goal is to, again, push it out as an open source repo and make it work with Unreal too.
Okay, and that would be part of the engine built in, or?
It'll be an extension. Like it'll just be a open source project that you can import in. Yeah.
Cool. Thanks.
Thanks.
I just Googled Otoy Orbex. It's a video codec. It looks like a cool video codec, but of course it's different to live 3D. So now the stuff you've been watching on the screen here, isn't video. It's live interactive 3D. That's the difference between glTF and Orbex.
Cool. Thanks for checking.
Hi. I've noticed you got the SIMP logo mentioned on the logo wall. So I wanted to, and I believe that they don't have support for glTF 2.0 yet. So I wonder if there is any suggestion for another C++ library to import and load glTF.
So I believe ASM does have glTF 2.0. I believe they merged the pull request, and I know they did a release around that same time. So I'm pretty sure it does have it. For other libraries that are doing C++ with glTF, there's I think it's called the Tiny Loader. We have on the main glTF repo, the README file has all sorts of different tools listed by language. So if you go there, there's a whole set of them that have C++.
All right, thank you.
Sure.
For the PBR material set, the extension, is there going to be some reference images, some ground truth images, so that all of the viewers get the material and the lighting correct?
Yeah, so this is a big topic. Maybe I'll take a first crack, and then I don't know if Scott or Ed want to give some information. But we've been thinking about conformance for glTF and what does it mean to have a correct rendering, and we want engines to do a good job implementing the format. But at the same time, each engine, they're going to have potentially different environment map, different sets of lights. So it is a little bit of an open discussion. So I would say it's TBA right now. Scott, do you want to chime in with your?
Yeah, I think, like you said, there's some differing opinions on this, but the reference implementation is kind of like a good baseline for a comparison of your own renderer, but we don't want to prescribe a specific visual look. We want people to be able to innovate. If you put this in a path tracer and have bounce lighting, or if you have your own occlusion models and things like that you apply to it, we want that to not be viewed as an incorrect interpretation of a glTF. So the reference renderer is there as an example of a starting point, but it's not prescriptive as to the final look.
Cool. Any other questions? All right, once again, thanks everyone for coming. Thanks for staying after, and big thank you to all the speakers.